Sometimes you hear about things that just, they really push the limits. Like, imagine an aircraft, this thing called the ALTO Zephyr, staying up for 67 days straight.
67 days.
Mm.
In summer 2025, that's not just pushing limits, that's setting a whole new standard, a world record.
A world record, exactly. And it wasn't just clever aerodynamics, right? There was something else powering that endurance.
That kind of flight time. It points straight to the power source.
Yeah.
You need a serious battery breakthrough for that. We're talking a fundamental shift, not just, a small improvement.
Right. So what was that tech? I'm guessing this ties into the company we're looking at today, Amprius Technologies. AMPX.
That's the one, Amprius.
Yeah.
Yeah, they're not your average battery company. Think material science, really cutting-edge stuff
Yeah.
that actually started back at Stanford University.
Teacher research, okay.
Yeah, and they were laser-focused on the big problem. Energy density. How much power can you actually pack into a battery? That's been the bottleneck for everything electric.
Got it. So for this deep dive, we're basically going to unpack Amprius. Look at their core tech, how they're trying to, roll it out. Starting with these, like, specialized markets first.
Exactly. High-value niches like the Zephyr, defense applications,
Mm-hmm.
and then seeing how or if they can bridge that to bigger things, like cars.
Okay, let's dig in. Where did this all begin? You mentioned Stanford.
Right, Professor Yikui's lab. So for ages, everyone knew silicon should be amazing for battery anodes. 10 times the energy of graphite, theoretically. The potential was huge.
10 times? Okay, so why wasn't everyone using silicon already? What was the catch?
The catch was pretty dramatic, actually. When you charged it, the silicon would swell up massively, like 4 times its original size.
Wow.
Yeah. And the expansion and contraction, it basically just pulverized the anode material after only a handful of charge cycles. It just couldn't handle the stress.
So it destroys itself. Not very useful.
Not at all. That's where Kui's breakthrough came in. Instead of a solid chunk of silicon, he developed these microscopic silicon nanowire.
Wires. Okay,
Right.
tiny wires.
Think of it like a dense carpet pile instead of a solid floor tile. Each individual nanowire pile has space around it.
Ah, so it can swell and shrink without breaking the whole structure?
Exactly. The space accommodates the volume change. It's elegant, really.
Yeah.
That structure is the key intellectual property, the foundation for Amprius, and it allows them to use a 100% silicon anode.
Okay, that makes sense. A really clever material science solution. So how do they turn that lab discovery into actual products? Are there different versions?
Yeah, they've developed 2 main product platforms from this core idea. First is their top-tier stuff, called Cymax. That uses the pure 100% silicon nanowire anode.
The highest performance one.
Right, pushing the limits, up to 500 watt-hours per kilogram. That's the kind of battery you need for something extreme like the Zephyr drone or, specialized military gear where weight and energy are absolutely paramount.
And 500 weight each kilogram. Just to remind everyone, that's a measure of energy density. Basically packing maximum power into minimum weight. Super important for flight.
Crucial. But they also realized, okay, not every application needs that absolute peak performance and maybe needs better cycle life or different characteristics. So in 2024, they launched
Secor. A different approach.
It's more of a composite. Still uses silicon nanostructures, but likely blended with other materials.
Yeah.
It aims for a balance, still very high energy, maybe up to 400 watt solo grade, but potentially better durability, longer life. Think of it as their pathway towards things like eVTOLs.
Electric air taxis, that kind of thing.
Yeah, and maybe eventually high-end electric vehicles. It's positioned as a more versatile workhorse.
So, 2 platforms. Cymax for the extreme edge, Secor for broader high-performance use. Makes sense. How did they actually attack the market with this? You don't just jump into EVs overnight.
No, definitely not. They went with a classic beachhead strategy. Target customers who really need the performance gains and are willing to pay a premium for it.
Aviation and defense.
Precisely. Lighter batteries mean longer flight times, more payload, longer missions. That's incredibly valuable in those sectors. So you get early revenue, often at good margins, and you crucially prove the tech works reliably in very tough conditions.
Smart. Build credibility, get cash flow. But scaling up production, that's
Yeah.
always the hard part for new battery tech, right? How are they handling manufacturing?
Ah, yes, manufacturing. That's been an interesting pivot for them. They initially announced this big plan for their own gigafactory in Brighton, Colorado.
I remember that. A billion-dollar facility?
Something like that. But they've shifted gears more recently. Now they're focusing first on a partnership with a contract manufacturer in South Korea.
Oh, interesting. So outsourcing the initial scale-up.
Seems like it. It's a much more capital-light approach. Lets them tap into existing manufacturing lines, expertise, and get product out the door faster, with less upfront investment and, frankly, less execution risk than building everything from scratch immediately.
Reduces the immediate financial burden and maybe some operational headaches.
Okay. The Colorado site isn't necessarily dead. Maybe it's for later phases or specific products. But the immediate focus is this partnership model.
Okay, so let's sort of wrap this up. What's the big picture here for you, our listener? We've got Amprius, born from real Stanford science,
A genuine breakthrough, not just hype.
with battery tech that demonstrably offers a step change in performance, world record enabling stuff. And they've smartly targeted these high-value early markets.
Right, so you have this core story.
Yeah.
The technology potential is, well, it seems undeniable.
Yeah.
World-leading energy density, validated and demanding applications. But that's weighed against the challenge of scaling up.
The classic execution risk.
Exactly. The science works. The market demand for better batteries is enormous. Can they bridge that gap? Can they industrialize this fantastic lab science efficiently and profitably? That's the billion-dollar question.
So if you're watching Amprius, what are the key things to track?
Definitely watch for customer announcements, new deals, especially bigger ones, or hints of traction in automotive, even if it's just development partnerships initially. That's huge validation.
And manufacturing progress.
Absolutely. How's that South Korea partnership going? Are they hitting production targets? Any news on the Colorado site's future role? And, of course, the financials watch their cash burn. Are they getting closer to making money on each battery sold? So positive gross margins.
Right, the path to profitability.
It's critical for long-term survival.
Okay, so a final thought to leave everyone with.
I guess it comes down to this. Amprius clearly leads with its patented 100% silicon nanowire tech. Can they translate that scientific edge, that unique structure, into the massive volumes needed for the EV market? Or will the sheer difficulty of scaling such a novel technology prove just too challenging? That's the ultimate test ahead for them.